Alright, so I just wanted to show you how you can get the third UAM equation on your reference sheet. Okay, so I'll just remind you that I already showed you where the first two UAM equations come from. Okay, so if you take the first one, you've got V final equals AT plus V naught, right? This is the equation of your velocity graph when you have constant acceleration, right? So that's the first equation on your reference sheet. Then you have this one here, delta x is 1/2 AT squared plus V naught t. Okay. Now in your reference sheet, this equation isn't in that form. This equation is in the form of x final equals x naught plus V naught t plus 1/2 AT squared. Okay, so I believe this is equation 2 on your reference sheet, right? And then there's also the other equation I showed you, where you can take the area of your velocity graph, which is in the shape of a trapezoid, and you get this equation, which is the average of the velocities times the time. Okay, so that's another one I've showed you. This is not on your reference sheet, right? So if I use this one and this one together, I can substitute in for time, and the idea is, can we make a UAM equation that does not require t? So if you don't know anything about the time, right, you can use one of these equations. Well, you can combine these equations. I'm gonna make a new equation that combines these two. Okay, so here we go. Make a new page first. I'll do this on another page. So I'm going to take the simpler one, and my strategy is going to be to solve a simpler equation for time. Okay, so I'll take the simpler equation, which is V final. This is the equation for the velocity graph when we have constant acceleration. Okay, so I'm going to take this equation and solve for t, right? So AT is going to be V final minus V naught. T is going to be V final minus V naught over A, right? So now that I'm going to plug this, I'm going to plug T into a more complicated equation. Okay? So a more complicated equation would be the displacement is the average of the velocities times the time. This is a UAM equation I showed you on another screencast. Okay, so I'm going to plug this in for time right there. All right, so let's see, I get delta x equals 1/2 V initial plus V final, and then in place of t, I'm going to write V final minus V initial over A, right? And I'll put vector symbols to show that these quantities are actually vector quantities. Okay, so I'm going to multiply both sides by 2, multiply both sides by A, and I get 2a delta x equals v naught plus v final. Let me write that a different way. Sorry. That might not be the best way of writing it. How about if I write v final plus v naught? So I've switched the order of these. And then this one is v final minus v naught, right? And again, these are vector quantities. Okay? So this is interesting because you may remember that this is actually a difference of squares. So this is v final squared minus v initial squared. That's kind of cool. Right? And then I can solve for v final, right? And I get v final squared equals v initial squared. So I switch sides with v initial squared because it was negative, plus 2a delta x. And on your equation sheet, it's not written like this. This is how I write it, but your equation sheet, I believe it's equation 3. It says, let's see, v final equals v naught squared. That's the same. V final squared equals v naught squared plus 2a, and there's a parentheses x. I guess they mean x final minus x initial. Okay? Now, these are the same thing. Same thing I have. But I choose to write it as the one above is the one I choose to write it as. So I like writing it this way. But, you know, the AP board writes it like that. Anyway, hope that helps. What's unique about this equation is this equation, which assumes constant acceleration. So this equation assumes constant acceleration, but does not require t. So that's kind of cool. Anyway, I hope that helps. We've material in the class in the last 12 weeks or 11 weeks. You know, we've done the first 1, 2, 3, 4, 5. We've done the first 5 equations on your reference sheet. And as time goes on, hopefully you'll see how all these things are connected. Anyway, have a good day, and thanks for watching.